Hello viewers, I am Dr. Mala Das Sharma, retired professor of St. Pius 10th degree and PG College for Women, Hyderabad. Welcome to my channel Chemphilic. Let's start 47th episode of Teaching Chemistry through Riddle. So here is our riddle number 47. A is a light metal. We find its wide applications in our daily life. When 1 Faraday of electricity is passed through the salt solution of A, the amount deposited in gram at cathode is a perfect square, and it is a perfect cube when 3 Faraday of electricity is passed. This is in accordance with the important laws of electrolysis. So, this is riddle number 47. Now, let's see the questions. The primary question is, who am I? The answer is metal aluminium. Second question, how much amount is deposited at cathode when 1 Faraday of electricity is passed? Answer is 9 gram, that is 1 gram equivalent of aluminium. Third question, how much amount is deposited at cathode when 3 Faraday of electricity is passed? Answer is 27 gram, that is 3 gram equivalent of aluminium. 27 gram or 27 is a perfect cube, and in earlier question answer was 9, that is a perfect square. Fourth question, state the laws of electrolysis as mentioned in the riddle. So first let us see what is electrolysis. If we take the aqueous solution of electrolyte, that is ionic compound or in the fused state, and if we pass electricity means the charge, flow of electron, that is negative charge, then what happens? We know that ions will move towards the electrode and either get deposited at the electrode or get liberated as gas. Okay? And you have to take one electrolytic cell. In the electrolytic cell, you have to take that electrolyte solution and 2 electrode. One should be attached with the negative end of the battery, that will serve as cathode, and another electrode will be attached to the positive end of the battery, that will be the anode. So when you are passing the electricity, what will happen? Positive charge or cation will move towards this cathode or negative electrode and get discharged. That means cation will discharge its charge and then either deposited at the electrode or liberated as gas. Similarly, the anion, that is negatively charged species or negatively charged ion, goes to the anode, and after going to anode, either it gets deposited, its charge is discharged, and it gets deposited or liberated as gas. Then what exactly happened here? In this process, this is the decomposition of electrolyte by passing the electric current. These electrolytes decomposed and liberated at the cathode. Say for example, you have taken zinc chloride solution. Zinc ion, that is the cation, will be deposited as zinc metal at the cathode. And the chloride ion, that is anion, will be liberated as chlorine gas at the anode. That means the two chemical substances of the electrolytes are produced at the different electrodes, or the electrolytes is decomposed. So this is the electrolysis. And this electrolysis involves the oxidation at the anode and reduction at the cathode. That means at the electrode, the reactions are redox reactions. Now, coming to Faraday's laws of electrolysis. So what we have observed in the electrolysis that when you are passing electricity, then the electrolytes are decomposed and getting deposited or liberated at the cathode. That means these ions are getting deposited, or the chemical substances are getting deposited or liberated by the electricity or the charge. So, the amount of the substance deposited at the electrode must be related with the electricity passed through the solution, and that is given in Faraday's first law of electrolysis. What is Faraday's first law of electrolysis? The mass of the chemical substance deposited at the electrode or the mass of the gas liberated is proportional to the quantity of the electricity or the charge passed through the electrolytic solution. Okay. In equation, how can you express that? If the mass of the substance, chemical substance deposited at the electrode is M, then M must be proportional to Q. Q is the quantity of electricity in coulomb pass. That means the charge, quantity of negative charge, electron charge passed through the solution. Now, if you want to remove this proportionality, we have to bring one constant. So, M is equal to ZQ. Z is the proportionality constant. Now, we know that this electricity, that is the total charge, that must be equal to the current passed to the solution in ampere multiplied by time of passing the current T in second. So, this Q is equal to C into T, where C is the current in amperes and T is the time in second. Then this equation now it will become M proportional to C into T, or M is equal to ZCT. So, what we have observed in the earlier equation, the mass of the substance deposited at the electrode, that is equal to either proportionality constant Z into Q, that is the total charge passed or electricity passed, and that is equal to ZC, that is the current passed in ampere, into T, that is the time of passing the current in second. Now, this Z, which is the proportionality constant, it is known as the electrochemical equivalent of the substance. And this value of Z depends on the nature of the ion liberated. So, it is electrochemical equivalent. Now, this unit of this electrochemical equivalent, see here, M is equal to ZQ. So, Z is equal to M by Q. So, what will be the unit? M, if you expressed in gram, gram by coulomb. So, gram by coulomb. Or if you express M, that is mass in kg, that is kg by coulomb. Now, how can you define this Z? So, look at here. If Q is equal to 1, that means if 1 coulomb of electricity is passed, then M is equal to Z. Okay, then how can you define? So, electrochemical equivalent is the mass of the substance deposited at the electrode when the electricity passed to the solution is 1 coulomb. Either this way or from this equation. See here, if C is equal to 1 ampere, T is equal to 1 second, then M is equal to Z. How can you define? So, electrochemical equivalent of the substance is equal to the mass of the substance deposited at the electrode when 1 ampere current is passed through the electrolytic solution for 1 second. So, this is the definition of Z. So, electrochemical equivalent of the substance may be defined as the amount of the substance deposited by passing a current of 1 ampere for 1 second or passing 1 coulomb of electricity. Now, coming to the Faraday's second law of electrolysis. So, now just imagine if you can pass same quantity of electricity to to different electrolytic solution, then the mass of the different substances deposited at the electrode for each electrolytic solution, will they follow any rule? And that is given in this Faraday's second law of electrolysis. So in the Faraday's second law of electrolysis, just what it is given that when we are passing same quantity of electricity through different solution, okay, or same current for same time through different solution, then amount of the substance of different electrolytic solutions deposited at their respective electrode must be proportional to the equivalent weight of the substances. Then how can you pass the same quantity of electricity through different solution, different electrolytic solution? Just see this one. This is nickel sulfate solution, copper sulfate solution, cobalt sulfate solution. And here is the battery. This is negative N, this is positive N. Now this negative end is attached here, this positive end is attached here, negative end is here, and these three solutions, they are joined in series. So when they are joined in series and when you are passing the electricity, same amount of electricity is passed through all the solution. Then amount of the chemical substance. See, here it will be nickel, here it will be copper, here it will be cobalt, which are deposited at the cathode. This amount of the substances deposited at the respective electrode is directly proportional to their equivalent weight of the substance. Now, just let us consider that M1 and M2 are the masses of two elements deposited by passing certain quantity of electricity through their salt solution. That means we have taken two salt solution of different substances, say nickel sulfate and copper sulfate, and same quantity of electricity is passed. Okay, and their equivalent weights of the substances are E1 and E2. Okay. And M1 is the amount of the first substance deposited at the electrode. So M1 must be proportional to E1. That means proportional to the equivalent weight of the substance, and M2 must be proportional to E2. So, what we can write? We have seen M1 proportional to E1 and M2 proportional to E2. So, we can write M1 by M2 is equal to E1 by E2. Again, from the first law of electrolysis, we have seen M1 proportional to Q or Ct. That means M1 by M2 is equal to this Z1Q. Z1 we have already told, electrochemical equivalent. Z1Q divided by, for M2 we can write Z2Q, or we can write for M1 we can write Z1Ct, for M2 we can write Z2Ct. That means finally we will get M1 by M2 is equal to Z1 by Z2. Now here M1 by M2 is equal to E1 by E2, and here M1 by M2 is equal to Z1 by Z2. So we can write E1 by E2 is equal to Z1 by Z2. That means the electrochemical equivalent of the substance is directly proportional to the equivalent weight of the substance. So, electrochemical equivalent of an element is directly proportional to the equivalent weight of the element. So, now, from here, from this equation, we can write that this electrochemical equivalent is directly proportional to the equivalent weight. So, we can write equivalent weight E proportional to Z. So, if you want to remove this proportionality, so E is equal to Z. F is the proportionality constant, which is known as Faraday. Okay. So from this equation, Z is equal to E by F. Okay. And 1 Faraday of electricity is 96500 coulomb of electricity. And what is the significance? 1 Faraday is the charge of 1 mole of electrons. Okay. And from this equation we can tell that when 1 Faraday of electricity is passed, then mass of the substance deposited will be equal to the equivalent weight of the substance. So, now coming to the definition of Faraday constant. So, already we have told the Faraday constant is the quantity of the electricity required to deposit 1 gram equivalent weight of the substance during electrolysis. Okay. So 1 Faraday or 96500 coulomb can deposit 1 gram equivalent weight of any substance during electrolysis. Say for example, you are doing the electrolysis of copper sulfate. Okay. Now cupric ion will get discharged at cathode and deposited as copper. So it will be losing 2 positive charge and deposited at cathode. Now 1 Faraday of electricity or 96500 coulomb of electricity can deposit equivalent weight of copper. Here equivalent weight will be molecular weight divided by 2. That means 31.75 gram of copper at the respective electrode. Now coming to some problems. Problem number 1. If 50 milliampere current is passed through copper coulometer for 60 minutes, calculate the amount of copper deposited. So here 50 milliampere current is passed for 60 minutes. So what is the total charge or total electricity passed? Electricity passed is current in ampere into T. Current in ampere, here 50 milliampere. So 50 into 10 to the power minus 3 ampere into 60 minutes. So it has to be converted to second. To 60 into 60. So 180 coulombs. Now here copper. What is the reaction? Cupric ion is reduced and deposited as copper. That means 2 electron transfer. So therefore, equivalent weight of copper will be molecular atomic weight divided by 2, that is 31.75. Now we know that 96500 coulomb or 1 Faraday can deposit 1 gram equivalent weight, that is 31.75 gram. So this amount of electricity or 180 coulomb of electricity can deposit how much? So 31.75 divided by 96500 into 180. The result is 0.05922 gram of copper will be deposited. Now coming to the second problem. 0.1978 gram of copper deposited by current of 0 ampere in 50 minutes. What is the electrochemical equivalent of copper? So current C is 0.2 ampere and it is passed for 50 minutes. So what is the total charge passed or total electricity passed? That will be equal to Q is equal to C into T. Here current is 0.2. T is your 50 minutes. So 50 into 60, that means 600 coulomb. Now we know that Q is equal to, already have written, Q is equal to C into T. Okay, and we got this 600 coulomb. Now we have already, it is given that amount of this copper deposited is 0.1978 gram. So therefore, from Faraday's first law of electrolysis, we know that mass of the substance deposited is equal to Z into Q. So Z is equal to, that is electrochemical equivalent will be M divided by Q. So Z will be equal to, what is M? M is 0.1978 divided by Q. We have already calculated how much total charge is passed, that is 600. So the answer is 0.003296. That means 3.296 into 10 to the power 4 minus 4. 1, 2, 3, 4. Now coming to the third problem. What current strength in ampere will be required to liberate 10 gram of iodine from potassium iodide solution in 1 hour? Okay. Now equivalent weight of iodine is 127 gram. So 127 gram of iodine is liberated by 1 Faraday, that is 96500 coulomb. So 10 gram of iodine is liberated by this much of coulomb of electricity. Okay, so this much of coulomb of electricity, and Q is equal to, we know that C into T. C is the current in ampere, T is the time in second. So what will be the current in ampere? Q by T. So Q is equal to this one, 96500 into 10 divided by 127. Then T. T is how much? 1 hour. 1 hour, you have to convert it into seconds. So 60 into 60. So result will be 2.11 ampere. So this is all about Faraday's laws of electrolysis and the associated problems. Thank you.